Hi, guys, and welcome back. I hope you had a restful week off. We're going to jump right in with more logarithms because we only got about halfway through our log chapter. So, today and tomorrow, we will be working with the properties of logarithms. Before we can work with the properties, we need to learn the properties. So, here are 3 laws of logarithms that you need to know. Now remember, a logarithm is an inverse of an exponent. Before spring break, we learned about switching from exponential form to logarithmic form. So the laws of logarithms are actually going to go really well with our laws of exponents that we've already learned. Our first law for logarithms is if you have a log of 2 things being multiplied together, then you can take that single log and split it into 2 separate logs using addition. Again, multiplication turns into addition. This is similar to one of our exponent rules. We had an exponent rule that said if you are multiplying 2 bases that are the same, you can change it to 1 base using addition. Now, this is a little bit different because it's taking one thing and splitting it into 2, but that main concept is there, right? We have multiplication and it changes to addition. So these are this is the rule that goes along with this rule for logs. All right, so going in that same direction, right? So we did multiplication changes to addition. So maybe you remember our rules for exponents, and you'll know that the next one is that division changes into subtraction. So if you have the log of a fraction or a division problem, you can change it into 2 separate logs using subtraction. Notice that the base on the logs stayed the same. They were log base b. And also notice that the bottom of the fraction went after the subtraction sign. So basically anything that's below a fraction bar needs to go after subtraction sign. It's making it negative. And here is the exponent rule that goes along with that. So we learned in chapter 6 that if you have a division problem, that you can subtract the exponents. And just like our log rule, you're doing the top one minus the bottom one. All right, we only have one more to go, and that one has to do with an exponent. So if you're taking the log of something that has a power on it, you can take your exponent and you can move it to the front of the problem, and it can turn into multiplication. So now this is mimicking the rule where we had a power to a power, and then we multiplied the 2 exponents together. What I like to do on this rule, I like to circle the exponent, and I'll draw an arrow going to the front of the problem. And remember, this is now k times the log of m, okay? That's it. 3 rules for logarithms. Now you do want to memorize these, and we'll work in class on creating something to help you memorize them. But for right now, let's go ahead and try to use them. Today we're going to focus on expanding. So I'm going to give you a single logarithm, and you're going to expand it out to multiple logarithms. The amount of logarithms that you will end up with will depend on how many bases there are. In this problem, I have an A, a C, and a B. So since I have 3 separate bases, I will end up with 3 logarithms. Each base gets its own log. Everything is going to be log base 10, and we learned before spring break that log base 10, you don't actually have to even write the 10. So if you don't want to write the 10 there, that's okay. I'm going to start by splitting this into my 3 logs. Anything that was on top of the fraction bar will get a positive log, so a plus sign in front of the word log. And anything that was on the bottom of the fraction bar will get a minus sign in front of it, because that's that subtracting rule. So I have a log of a to the 5th, a log of c, and then minus a log of the square root of b to the 3rd. Now this is taking care of our first two rules of logs. Multiplication turns into addition, division turns into subtraction. Now we need to use our third rule. To use our third rule, we need to have everything in exponential form. So I will need to change that b from radical form to exponential form. Remember that there is an index of 2 on this. And so I'm going to put a 2 on the bottom of an exponent. So now it's b to the power of 3 over 2. The index goes below the fraction bar. And then if you want to, you can circle your exponents. And you're pushing them to the front of the log that they were attached to. So that 5 will go in front of the a. The 3 over 2 is just going to go right in front of this log. And the c did not have an exponent written with it, so I don't need to put anything in front of that log. Here is my expanded form. That's it. So we're taking a single log and splitting it into multiple logs. I would like you to try the next ones on your own. So go ahead and try these 5 on your own in your notes. Pause the video, and when you're ready, go ahead and restart and we can talk about the answers. All right. Now I hope that on each of these you got a total of 2 logs because each of these just has an a and a b. So you need a log for the letter a and a log for the letter b. Let's check and see how we did. On the first one, I got 2 log of a plus 1/2 log of b. Remember that radical turns into a fractional exponent. On the second one, I got log base 3 of a. Now this time I'm saying the base because it's not a base 10, and so that is important that you write down the base of 3. And then minus, because it was a fraction, 2 log base 3 of b. Number 3 was a little bit tricky. Make sure that you distributed your exponent to your a and your b before you expanded. So since the exponent of 3 gets distributed to both letters, right, here and here, both of my logs will end up with a 3 in front of it. Same thing on number 4. On number 4, since both of the letters are underneath the radical, they will both get a fractional exponent. So the a, which did not have an exponent, is going to get a exponent of 1 over 3. And the b, which did have an exponent, will have 2 over 3. And that's where I got those fractions from in front of the logs. Finally, on the last one, both of the logs need to be negative because a and b were both underneath the fraction bar. So make sure that you put a negative sign in front of the log of a and a negative sign in front of the 1/2 log b. All right, now maybe you're wondering, what happened to the 1? Like, why didn't I do log of 1? So now technically I did log of 1, and if it was any other number in the world, except for maybe 10, it would show up as part of the answer. You would have like log of 2 or log of 5 or whatever the number happens to be. But log of 1 is special, and we learned this again prior to spring break, and we'll do a little review during our live class session. But the log of 1 is always 0. So since the log of 1 is 0, I mean, basically it's like I can put a 0 in front of this, but that doesn't really do anything. So I just left it off. Now in my work, maybe I would have written this down. Or as we get a little bit more comfortable with logs, maybe we will memorize that the log of 1 is always 0, and then we don't have to write it down. But that's why the log of 1 did not show up in the answer. Okay, so that's it for today. Today we're just going to be expanding, so taking a single log and splitting it into multiple logs. Tomorrow we'll work backwards. We'll take multiple logs and we'll squish them into a single log. Until then,